Myself and Kalpna. I am from G.K.Jain Higher Secondary School, Raipuram. Today, for the 10th standard, I am going to explain the topic is laws of motion. So, in this lesson, it is fully deal with the gravitational force, acceleration, velocity, like that. If you have know the terms, gravitation means we know the scientist Newton's. So before that we have to see the Newton's three laws of Newton's. Okay, let's see the first law of Newton. Newton first law of it states that a state of rest or an uniform motion unless some external force applied on it. Okay, let's see the example. When if you have put some stone on the ground, what happen if you're not kicked up? That means if you're not given some force, it should be in the same state. If you have kicked up, what happened? It should be change its velocity, change its state. That will be called it as a Newton's first law. So unless you have given the external force, it cannot be changed. Whichever it is not be changed, first one, the rest will not be changed. Second one, uniform motion will not be changed. That is the first law. And let's see the second law. Third law. Before that, seeing the second law, we should see the third law. An example for third law. If you have throw the ball on the ground, what happen? If you have throw it, as soon as possible, it has get back to the original position. Okay, isn't it? So how much of speed, how much of force you have given, that much of force it has been get back, isn't it? That is the example. That is the Newton's third law. For every action, that is, you have to throw the ball with the force. For every action, there is an equal and opposite reaction. That will be called it as a Newton's third law. Formula for Newton's third law is, let's see force. If it is a force, and we know F1 which is equal to force, which is action, which is equal to the opposite, that is minus, which is positive, so it should be negative 1. And next one, the term momentum. So what is mean by momentum? It is a quantity of motion only. It is a product of mass and velocity. How the motions have been dealt with the product of mass and velocity. So next we see the Newton's second law of motion. Newton's second law of motion, it deals with the force which is directly proportional to the change in momentum. That is why I am explaining before the momentum. So momentum means product of mass and velocity, isn't it? So second law deals with the force which is directly proportional to the change in velocity. Directly proportional means if the force is increasing, the change in momentum is also be increasing. I already told that. Okay. Let's see the derivations for the formula for the second law of motion. First one, so change in momentum. Usually the symbol delta which represent for the changes, isn't it? So P is the symbolic way of representing the term momentum. So change in momentum means change, it has been represented by the delta. So delta P. Let's see P1 initial state, mass, and U is a velocity. Usually velocity it has been denoted as a V only. Okay. But in the case if it is have shown the changes means you have to describe it as a U and V. If it is an initial state, it should be U. As if times going on, it can be changed as V. Okay. Let's see that. Momentum first at the initial state. P1 equal to M into initial velocity U. And next P2 equal to M into V final velocity. Next one, changes in the momentum. Usually changes means you have to subtract the final moment, final step, then initial step. Then you have to conclude at the how much of changes it has happened. So delta P equal to P2 minus P1. So what is the value of P2? MV minus MU. Mass which will be the common for the term. So you can be kept the mass as the common one. M into V minus U. So V minus U is the change in velocity. We know the term change in velocity means it indicated as a acceleration. What is mean by acceleration? Change in velocity. So in place of change in velocity, that is V minus U, you can be substituted that symbol A. A means acceleration. So F which is directly proportional to the change in momentum, M into A. So F which is directly proportional to MA. This is the second law. And next one, impulse. Impulse, it is term denoted as, generally impulse means it is dealt with the force with respect to time. Okay, it is one way of definition. Impulse means a force with respect to time. Okay. So J, which is representing the term impulse. So J equal to force with respect to time. The unit of force is Newton and the time is second. So NS is the another way of representing the impulse is, let's see that it included the momentum as well as the second law. So you know that momentum means P. What is the momentum? P equal to product of mass and velocity, isn't it? Newton's second law, force which is directly proportional to ma. The same we have to be used here. F equal to ma and P equal to m into v. Okay, let's see that. So F equal to ma. Next one, A. Let's see the A. A means acceleration. Acceleration means change in velocity with respect to time. So F equal to m into velocity. Change in velocity you have to describe as delta v. So delta v by t. Okay. We already see that momentum P equal to m into v. And normal momentum means product of mass and velocity. But here it should be a change in velocity. So automatically it should be a change in momentum. So mass into delta v by t equal to change in momentum. So F equal to change in momentum, we have to indicate it as a symbol delta. So if you have seen that changes mean, you have to put the symbol delta. So delta v by delta equal to change in momentum. So in place of this, we can be substituted F equal to m into delta v. So m into v means momentum as usual P. M into delta v means change in momentum, that is delta P. So F equal to delta P by T. Next one. So we know that F equal to, so in place of F we have to substitute it. So J equal to delta P. So impulse J can be represented in the two way. One is it has been dealt with the force and the in terms of time. And the second one, impulse is nothing else, change in the momentum. The unit of impulse in the change in momentum is kg meter per second. And the next topic we have to see is conservation of linear momentum. So in this conservation of linear momentum, it has been dealt with the Newton's second law as well as the third law. Just see that if you have considered a ball A and the other one will be a B. So whose mass will be m1 and m2. So the mass should be the same thing. After some times we have to drop the ball. It has reached some level. So both A as well as B, we have to drop it. It has reached some level. So automatically the mass should be the same one, but the velocity, the distance traveled should be differ. So initial it should be u1 and the next one u2. For the second we have considered as a v1, v2. Okay. So two masses will, two different velocity will be. Okay. Let's see that Newton's second law as well as the third law. What is the formula for Newton's second law? F equal to ma. Newton's third law, F1 which is equal to minus of F2, isn't it? So first see the Newton's second law. F equal to ma. A means acceleration, change in velocity. In place of A you can be written as A or else V minus U by T. Okay. First one, force on body A due to B. So what happened? The force will be act on body A which is due to body B. Okay. So we have to consider the force of A. So Fa equal to whose mass is. So we have to apply the Newton's second law. F equal to ma. M1 acceleration. V minus U. V1 minus U1 by T. And next one, force on body B due to A. The same thing will be there. So Newton's third law, F1 equal to minus of F2. We have to substitute it over here, F1 as well as F2. So finally, what we have to conclude in this conservation of linear momentum, in the absence of external force, the force before the collision, the momentum before the collision and after collision should be the same. So some momentum will be there. So it should be having the collision in it. So if you're not applying the force, if you not send the external force, it should be the same one. This is we have to conclude it from the conservation of linear momentum. And next one, let's see the rocket propulsions. Okay, in this rocket propulsions, it has been dealt with the conservation of one of two. It has been linked over here. Okay, most of the laws have been based on it. So in the rocket propulsion, we have a based on conservation of linear momentum as well as the third law. First see the points. First, fuel. So before the sending the propulsion, the rocket, it has been filled with the fuel. It should be either liquid or else should be a solid. So first thing, you have to fill with the fuel. And second one, after filling the fuel, we have to burn. The fuel started to burn. It has been ejected the fire with the force. Okay. So after it has been burned, the fuel have been burned. It has been emitted a fire on it. Okay. And next one, third one, to balancing. So for what happen if you have burned one side, it has been with a large force, the fire has been come. So third one, action and reaction. So what happened to balancing the force, the rocket has to started to move in the other direction. The fire has to come in that thing with the huge force. To balance it, it has been in the upward momentum. And next one, automatically the fuel has been burned. No. So the mass of the rocket has been reduced. Before that, we have to measure the mass with the fuel. So after it has been burned, the fuel has been reduced. So mass will be reduced afterwards. And next one, if the mass has been reduced means fuel has been burnt in it. Automatically the velocity, the moving speed, it has been increased. It has been moving more and more distance it has been covered. And next one, at one stage, what happened? It has been escaped from the gravitational force. Okay, it escaped from the gravitational force. Those velocity, again it also move it. Those velocity will be called it as a escape velocity. These are all the important points for the rocket propulsion. So in this video, we discuss about the 3 laws of motion. These are very important on that. So based on the 3 laws, we have to derive some equation, momentum, conservation of linear momentum, rocket propulsions, etc. Thank you.